Question number one is a train is traveling horizontally in a straight line. A book is on the table in the train. The diagram shows all the forces acting on the book. How is the train moving? Listen, the book is placed on the table. There is friction in the forward direction, upward contact force, normal downward weight force, and the book is at rest. So, how is that train moving? The train is accelerating towards left of the diagram, accelerating to the right of the diagram, moving at uniform speed to the left of the diagram, or moving at uniform speed to the right of the diagram. Yes. What do you think?
I'm thinking about it.
Okay, hurry up, think about that and be quick. Come on.
Is it? I'm not sure, but is it D?
Yes, sir. It
Okay,
might
yes,
be.
it is D. Anyone
Yeah.
else? Oh, good. So, if you people think that, why is it D? Who will explain that why it is D? Delta, why it is D? Did you see all the forces here? Did you notice this force? This force.
Yes, sir.
Okay. If friction is there, then uh, the book is at rest over there. The book is at rest on that table. Okay. It is not moving or anywhere, but there is a forward friction. It means there there is a force this way, which is um, actually trying to move the book to any one of the sides to which the friction is opposing it. Listen, this is actually that a train is traveling horizontally at straight line. The book is on the table on the train. The diagram shows all the forces acting on the book. So up and down balance. Okay, up and down balance. Train is moving, and if the train is moving with constant speed, check karo. If the train is moving with constant speed, then towards the right, because your option was D. So I'm going to explain that one first, and then I will move to the true answer. I'm going to give you the logic so that you will be able to understand that. If it is moving with a constant speed, will there be any net force acting towards right?
No.
No.
No, there is not a chance for any of the forces acting on the right. So there would be some force which would be balanced. Is it?
So is the answer C?
Can
Okay.
I go
Again,
with
it is not
A?
uniform. Okay. If again constant speed towards left, then definitely there should not be any force, unbalanced force along the horizontal direction. So there is the acceleration. The train is accelerating. This is understood. That train is accelerating. So these two are gone. So accelerating to the left of the diagram. If it is accelerating towards left of the diagram, then force should be on that side, isn't it? Are you
But
getting?
isn't the frictional force opposite to the actual
Net,
force?
to the applied force, or to the force which is basically acting on the train, or acting between the surface of the train and the book. Listen, it's very simple to understand. Just if this table is movable, okay, now just consider that actually the table is part of the train. Na? Table is fixed with train, is it?
Yes.
Okay, so if the table is fixed with train, actually just consider that this is train. So when it will be moving forward towards this way, then what will happen? If it is accelerating in this direction, it means it will cause it will cause a force on the book, which will it is speeding up. Actually, I'm going to make you clear in this one. It is speeding up. Acceleration mean it is speeding up. So when it is speeding up, the book will not have any uh, gear or engine or anything else. So book will left behind. I mean, book will be lagging behind. Is it? Are you getting my point?
Um.
देखो मैं बताता हूँ. Book is just consider yourself in the train or in the car. When the person in the train is gearing up the car, sorry, not in the train, in the car. When we speed up the car, what happens? आप पीछे मूव करते हो या आगे मूव करते हो?
आगे.
Never. When you apply the brakes, then you move forward. When
Oh
you speed
yeah.
up the car, you move backward. Why? Because your car wants to leave you. Is it? Are you? Is this clear to you? Your car wants to leave you, people, but because of the friction between seat and your body, you are not left by the train. I mean, train. That car keeps you with you. Your body is kept with the car. That is why, if if the friction is in this direction, if the friction is in this direction, it means book was trying to move here. This was the motion of the book. So to compensate this, what happens? To compensate this motion, the friction appeared in this direction. Is it clear? So that is why it is obvious that the train is gearing up, train is speeding up. That is why book is moving backward due to inertia, or you can say book is um, trying to maintain its position because it does not have an engine, and friction opposes it by applying a force towards right. So this was very tricky
But then,
question.
how do we know that it's moving from in a constant speed again? I mean,
No,
in
no,
a
no. Constant
accelerating
speed
again.
means there should not be any force existence of the force. We must not have any existence of force.
June 40.
Listen again. I'm going to tell you this question again. This was the one of the best questions for the forces, which appeared in the exam. Best for the examiner, but not for the students actually. Okay. So listen, what is the philosophy of this question? That do you see that there is a force mentioned there? There is a resistance force mentioned. I'm going to make a bit thick arrow. That is the resistance force. Okay. This side resistance force means frictional force means that book wants to move in which direction?
Other opposite direction.
Opposite direction, right? It means book wants to move, or book is trying to move in this direction, and book will try to move in this direction. This is basically the possible direction of motion of book. Possible direction of motion of book. And when book is trying to move in this direction to keep its position, what do we have? We have the friction in the towards left, towards right. This is the friction that opposes its motion, and the motion of the book in this direction is just due to what? Because the train is speeding up. Okay, train speeds up, and book is not having any engine. That's why book's velocity is same. For example, listen, book speed is suppose 20 meter per second, right? And the speed of the train was 20 meter per second. Now the engine of the train is applying some force from the engine, and its speed becomes 25 meter per second. From where this 25 meter per second will come in the book? Will this book be able to gain that speed?
No.
No. So what will happen? If you imagine that these are two different setups, then book will left behind. The train will leave the book because it is slow. Just detach them. Just detach both the systems. Then what will happen?
Yeah.
Book will left behind. I mean, book will be basically fell over after some time. Book will move this way, right? I mean, book will remain on the same position, but train will uh, leave it beneath. The train will leave this book because it is accelerating, and book cannot accelerate with that. That is why the book will be trying, our book will, it's, I mean, it will be apparently we will say that book is moving towards left. हालांकि ऐसा नहीं है, book is not moving towards left. Actually, train is moving towards left, accelerating towards left, leaving the book on its place at moving at 20 meter per second. So that is why the friction is required towards left side, sorry, towards right side, to keep this book on the same position. Now is it clear?
Yes, sir.
Khadija, clear है बेटा? Khadija, Mariam, Ariba. Hello.
Sir, how do we know that it's accelerating and not moving at uniform speed though?
हाय हाय, इतनी देर यही एक्सप्लेन करता रहा हूँ.
No,
देखो,
but like if you're not given the amount of time, you know?
no need to give you amount of time. Okay. Go back to this. If I place a block on the car's head or car's roof, right? Okay. Is it clear? Are you going to understand this question? The car is moving forward with a speed of 20 meter per second. Same is the speed because both are in equilibrium, so it is also moving with a 20 speed of 20 meter per second. Is it? Are you getting it?
Yes,
That's
sir.
why it is. That's why it is. This bag is on the car, na. Otherwise, why bag will be attached with the car? It does not have any, harness or anything. We had not fastened that with the belt, so its weight is downward, its normal reaction force is upward, and this bag was moving at the same speed of 20 meter per second. Is it? Are you people getting it? Its speed was 20 meter per second. Now suddenly the driver speeded up the car, accelerated. So Ariba will tell me what would happen to the bag. Will it move backward or forward?
Well, the people would move back.
Not people. I'm talking about the bag, which is on your
There is
on.
Oh, yeah,
force of
that
inertia.
would go so back it falls off.
Yeah, it will move forward. It will go back, na. It
Yeah.
will go back. Khadija, बस मैं तुम्हारी बात पे आता हूँ बेटी. It will move. It will go back. Why? Because when the driver was moving at the speed of 20 meter per second, this was at rest because its speed was maintained 20. Just suddenly, driver accelerated towards right, and bag go back and falls off. Is it? Are you people agreed? It means
Yes, sir.
if we don't want the bag to fall off, what should be the direction of the friction? This should be the friction, isn't it?
Yes, sir.
Now is it clear?
Yes, sir.
Khadija, Mariam, Ariba. Yes, Khadija, what was your question? Can you please ask me now?
These all forces related to inertia.
Yes, it is game of inertia actually, because due to inertia, your bag will try to maintain its position, but if we will not have any friction, what will happen? The bag will fall off.
Yes, sir.
Mariam, clear हुआ क्वेश्चन बचा?
Yes, sir.
ओके, और अरीबा आपको भी
Yes, sir.
पक्का ना? ऐसे मरा हुआ यस सर नहीं चाहिए मुझे चाहिए एनर्जेटिक यस सर. हाँ,
Sir, it's because I woke up a while ago, but like, yes, I understand.
okay. Next question is, a cyclist is traveling in a straight line along the horizontal road at constant speed. At constant driving force, F acts on the cyclist in the forward direction as shown. Again, a horrible question. Again, a horrible question. So we can say that if a constant, a cyclist moving a straight line in the horizontal road, a constant. Yes, here is the key of this question: constant speed. So if it is moving with constant speed, there is a forward force, a constant driving force. A constant driving force is acting on the driver, I mean the cyclist, in the forward direction. Which statement about the magnitude of the frictional force acting on the cyclist is correct? Its magnitude is smaller than F, magnitude is equal to F, magnitude is greater than F, magnitude is 0. Yes. What would be the right option? I have given you two key points.
Constant speed in a constant driving force.
Yes, 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 yes. Come on.
Um,
Yes. अब तुम लोगों को ये बताओ कि कोई भूत नहीं पढ़ा रहा कहीं, मैं खुद ही हूँ. बताइए जी. Okay, key points. Did you notice the key points?
so what does it mean by it? The constant driving force is acting on the cyclist. Like,
Actually,
isn't he the one who
cyclist,
is
yeah,
putting
cyclist
up the
is
force?
applying the constant force by pedaling.
Oh, okay. Then,
Sir, is it A?
yeah, I also think it's A.
Okay, and Ariba, what do you think?
Sir, the question just got back on my screen. I'm reading it right now.
Okay, okay, read it and then let me know.
Then speed. And
Yes, now you got it. Constant speed with a constant driving force. You know, I have given you a concept of that F driving and F resistance will be subtracted to give you net force. F net is equals to F driving minus F resistive. So if F net is equals to 0, then F driving minus F resistance will be equals to 0. It means driving force is equals to resistive force. That's why the magnitude is equals to F. Is it clear, Ariba?
Yes, sir.
Sorry, I have not given you the chance to explain your question, but felt that I must explain it to you. So that is the same resistance force moving acting in opposite direction. Okay, should I move to the next question?
yes, sir.
Okay, अभी तुम लोगों ने भी तो मूव करना है ना क्वेश्चन पे. Yes, it is again a question of a student measuring the length of a spring. She then attaches the different weights to the spring. She measures the length of each. Oh, sorry, sorry. This is from deformation. Just leave it. Okay.
Sorry, so we
So,
are not doing this?
ना अभी नहीं करेंगे. We will do it, but when I will be done with deformation. Okay. Because
Okay.
I have completed forces and momentum, so I'm just hunting those questions which are from that topic. Okay, now check this one out. This is your question number 5 of this chapter. A tennis ball has a mass of 57 grams. Okay, this is the mass of that. And then the tennis player hits the tennis ball with the tennis rackets. The tennis ball has a velocity of 25 meters per second when it hits the hits the rackets. The velocity of the tennis ball when leaves the player's racket is 15 meter per second in opposite direction. from its approaching direction. Yes, the average force exerted on the tennis ball is 35 newton. For how long the tennis ball is in contact with the tennis racket? Yes. Who will try to, or who will help me to solve this question? Yes, hurry up.
Is it C?
See? Okay, let me check.
It's like impulse is equals to, change in momentum.
Okay.
So
Hmm.
final minus initial. And then,
Okay, good, 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 good. Good explanation. Final minus initial is
yeah,
basically
we get,
change in
mhm,
momentum. Okay?
we will
It
like
is basically,
multiply.
yes,
I think
exactly.
C, sir.
C. Okay, Ariba also agreed at C. Mariam, what is your opinion?
C.
Okay, so all of you are agreed at C. Well done. So should I explain it? No need?
So could you please?
Yes, I would like to have its explanation because um, as you people told me actually that change in momentum is something like this. Here is its solution. Force is equals to delta P divided by T. And this is, rebound case. सबसे important is the most important that it is rebound case. What is that? Rebound. Mean the ball hits the racket and then it moves in the opposite direction. So you have force, you have change in momentum. Change in momentum is what? M into V. I told you in case of rebound, what will you do? You will use
Minus.
M plus.
Plus.
No. Plus karoge. So M plus V plus U. Okay, V plus U and divided by T is equals to force. So what force do we have? We have the force of 35 Newton. And what is mass? 57 gram is actually 0.057. Final speed is the speed by which it is leaving. It does not matter. You are adding both the speeds, so you can just write them simply. 25 plus 15 is same as 15 plus 20. So time will be equals to, just multiply these all numbers, 0.057 times 40 divided by 35. So what answer you are getting?
Okay, I got it. It's C.
C. Yes, no problem. So that is why it is C. The next question, question number 7.
Sir, the next question is question number 6.
6, 7. 6, 6. Sorry. Oh, sorry. C is this one. C of this. Yes. Question number 6. Yes, Ariba, are you doing it?
So it's the answer D.
तुम जल्दी जल्दी आंसर बता देती हो मुझे. Why?
Yes, sir. I also think it's D.
D. Okay. And where is Ariba? Is Ariba thinking answer is D?
Because like mass into,
Mass
acceleration.
into acceleration. And then you subtract it with the total force.
Yeah.
Is Ariba in the class? Let me check.
Yeah, I'm here.
बोलती नहीं हो आज, क्यों खैर है? नाराज हो? Hello?
Um,
Sorry, sir. I was speaking and I was muted. I was saying that I had woken up a little while ago, so I was just a little bit, slow on the intake for all the information. I was trying to
Mm-hmm.
remember the formula for this.
Okay, so is it now fine for you? You did it?
Yes, sir.
Huh? Okay, okay. So for this one, yes, you people are right. Answer is D. I D बताया ना आप लोगों ने?
Yes, sir.
Okay, because here is in this question actually the situation is related to your uh, I mean the same as driving and friction force I told you. Okay, driving and friction force means when we are having uh, F net equals to F driving minus F resistive. So F net is equals to your MA. I'm sorry, the space is very less in this, but I will try to solve here. MA F driving is how much? F driving is 50 Newton force, and F resistive is not available, and M is 10 kg, and acceleration is 0.5. Okay, so 50 minus driving force, so just 10 into 0.5, it will become 5, and that will be 50 minus driving force, and driving force will be shifted on the other side, and driving force will be having the answer of 45 Newton. Is it
Yes, sir.
clear? Next पे आइए जरा this question, because the question was not that what I made it, but now you can see the question. Question number 7.
C.
Okay, sure.
Yes.
यस ओके, चलो मैं एक और बच्ची से पूछता हूँ. 1 मिनट होल्ड करिएगा. आई एम जस्ट आई हैव पुट ऑफ माय हेडफोन्स, सो जस्ट 2 seconds प्लीज. यस प्लीज. आर यू पीपल एग्रीड दैट ऑप्शन इज सी? एवरीवन?
Sir, I think it's C.
हाँ, बाकी लोगों ने आंसर किया था व्हेन आई वाज नॉट वेयरिंग द हेडफोन्स.
No, sir. I mean, there's this Adiba in the class.
ओके, वेयर इज
I,
खदीजा?
I was double doing my calculation. I also think it's C.
ओके, थैंक यू. बाकी नहीं देकर गए?
I think their internet disconnected.
Yeah.
खदीजा इज डिस्कनेक्टेड.
Yes, sir.
Okay, no break. Okay, so that, yes, that is C. You people are right. Again, same formula. Driving is 4,000 minus 1,000, 3,000. 3,000 divided by 1,200. So 3,000 divided by 1,200. That will be your 2.5. Okay. Next question. Question number 8 and 9. Well done. Well done. Well done. Well done. Momentum पे लेके आता हूँ just after these two questions. Question number 8 and 9. Yes, any response?
So why does this question look so simple, but it is not?
What is the value of the resultant force acting on the object? It is simple, but not that much.
Sir, you're scaring me because I already solved that question and I was solving question 9.
Okay, you did it.
I think.
Okay, okay. Then after that, when Mariam will be done, then we will declare the answer. Yes, Mariam, are you stuck?
Is it? Wait.
Okay, then what about 9?
I've not even looked at that.
Okay. So Ariba, yes. What's your answer for C? For 8? Okay. There is no Ariba at all?
No, there is, but like she's muted.
Okay, okay.
Um.
So let me solve this for you people. I think Ariba will hear that. Because 9 Newton is acting towards right and 1 Newton is acting towards left. So that is why both of these forces will be subtracted, and you will get a resultant force along x-axis that will be actually equal to, that will be 8 Newton in this direction, and 6 Newton is here. So now 6 and 8 are at right angle to each other, and due to this property, you will apply Pythagoras theorem on that, and this will lead you to 6 square plus 8 square root. So it would be 100, and then when you are going to take its square root, the answer will be 10. Okay.
I totally forgot about the Pythagoras rule.
Yes. So what did you do then?
I got the answer of A. I thought you had to subtract both of the resultant forces.
Oh yes, that was. We have subtracted both of them, but there is one, force which is acting to the top. So when we have to consider that also. Okay,
Okay.
Got it, sir.
is clear? Then question number 9 is, the stone is dropped from the rest from the height of 10 meter above the surface of the planet. The planet has no atmosphere. It means no resistance. The speed of the stone just before it hits the surface is 3.8 meter per second. What is the acceleration of the free fall? Oh my God. Huge question. Yes.
From rest.
Yeah, it has dropped from rest. Its initial speed is 0. And it has traveled 2 meter above the surface of the planet. And no atmosphere, no resistance. The speed when it hits, it is V is given to you, and you are going to have mm,
Right.
definitely there will be some sort of acceleration, and we need that acceleration to find out. But for that purpose, we are not having any sort of
Time.
information. Hmm.
We don't have time.
Which we do not have time. So let me think too. Yes, its height is, because there is no work done against friction, so loss in kinetic energy, Ke, sorry, loss in GPE. Yeah, there is only one way to solve this question. Loss in GPE, that is equals to gain in Ke. Okay, so loss in GP is your mgh, and then that is equals to 1 by 2 mv square. Just figure out, mass cancelled out, and you are going to find value of g, so which is equals to v squared divided by 2 into h. Wow, what a question. Yeah, so when it hits the ball, I mean when it hits the ground, its speed is 3.8. 3.8 square divided by 2 into 2. So just calculate this, please.
3.61.
Yes, that's why its option is C. So I believe that it was one of the horrible questions.
Sir, but where did loss in GPE and gain in kinetic energy come from?
Yeah, actually, this question will not be solved by the ordinary technique of forces. Remember one thing, because when we are going to drop it, na, listen, here it is that stone or that object, and when you are going to drop it, its speed is 0. It means it has no kinetic energy, but it has highest GPE at that point. But when you drop it to this point, it has the highest speed, 3.8 meter per second, but here its GPE is 0. So all of the kinetic energy, all of the gravitational potential energy is converted to kinetic energy. That's why I use that formula. So this was actually the situation. I believe that you people are clear about these questions. So now I believe that you people must try the questions at home, because without trying these questions, it is not possible to solve them. Okay?
Could you explain it one more time, sir?
Yes, I can. Should I?
Yes, please.
Okay. So when a stone is at the highest point over here, its speed is 0, because it is dropped from the rest. When it is dropped from the rest, we say that its kinetic energy is 0. Okay. What is kinetic energy of the stone? That equals to 0. But as it uh, drops down and down and down, its kinetic energy is increasing, is it? And gravitational potential energy decreases. Kinetic energy increases and gravitational GPE decreases. So loss in gravitational potential energy becomes equals to gain in Ke. Okay, that's why I will put all the values here. Kinetic energy का formula क्या है? 1/2 mv² and gravitational का formula है mgh. So m and m will be gone, and you will have, because you need find value of g at the of the planet. So g will be made a subject. H is multiplying with g. It will be divided on the other side. So it would be v² divided by 2h. Just plug in the values. V square is 3.8 whole square divided by 2, and height was 2 meter, and you will get 3.6 meter per second square. Is it clear to you?
Sir,
Mm-hmm.
in
Yes.
question number 10, we use the formula of weight to find the answer. So basically, in question number 10, the tension is the weight.
Okay. Tension is the force which is holding it. Yeah. Ariba, was question number 9 now clear to you?
Yes, sir.
And now, are you working on question number 10 also?
I'll try now.
Okay. There is one keyword. Yes, Mariam, what were you talking about this
I'm
question?
saying is the tension force weight?
Tension is not weight actually, but it compensates weight.
So are we using the formula of weight or?
We can use the formula of weight, but logically, because it is held stationary. Held stationary means whatever the amount of force it has in the downward direction, it will be the same as the upward direction. So tension will be as same as its weight. That's it. This is the trick for this question. So tension will be
Oh,
20 times 9.8. So that is 200 Newton, almost 200 Newton. Okay, so these were the questions for you people. I believe that now it is clear, na, Ariba? Beta, now I have decided to move with a proper sequence. This was the topic from the force. You have to do this all, and the topic from the momentum, page number 89. I have mentioned that, na. Just leave this circular motion 1.7. No need to do that. 1.6 and 1.11 are two homeworks. You have to do it completely.